Welcome to the lecture Game Design and Game Development. In this lecture, we want to start our own project development with the topic of creative techniques. To make it easier to find the relevant information later, we see the list of content here. When you want to start a creative software project, the question often arises whether the creative phase is best done alone or in a group. It has been found that brainstorming in groups often yields better results. Usually, a larger set of solutions results, and also the variety of solutions is often larger and more interesting. The important thing here is to get together in a group that is very heterogeneous. A moderator can play an important role here and coordinate the process of finding ideas. Care should be taken to ensure that there are no hierarchical constraints in the group. This means that if the boss is present, he may only be looking for confirmation of his good ideas. When we think of creative techniques, the term brainstorming certainly comes to mind. It is representative of a whole range of creative techniques. However, there are other techniques besides the classic brainstorming. We see a few important examples listed here, which we will get to know in the further course of this lecture. Let's start with the classic brainstorming approach. The classic brainstorming takes place with 5 to 7 people. A moderator introduces in the problem. There are 2 phases in brainstorming. In the first phase, everyone is allowed to express their ideas without contributions being criticized or evaluated. Ideas that have already been presented may also be combined or extended. The rule is quantity over quality, and the more creative the ideas, the better. Subsequently, the ideas are filtered. For this purpose, the ideas are presented in summary form, evaluated together, and then sorted. Let's take a look at an example from the year 2010. In the context of the lecture Artificial Intelligence, a project should be developed with the following conditions. It should be a lobby installation, Visual Studio and Unity should be used, real-time vision should be employed, only gestures and speech were allowed as communication with the system. The application should be intuitive, contain neither violence nor blood, and be interesting for all age groups. From the brainstorming, an idea emerged in that a world is to be seen in which a small, cute protagonist lives. Associations of the ideas were found, for example, with the hobbits in Lord of the Rings or in Findus and Petson. Initial concept sketches were created. A plausible world had to be created for the protagonist. This allows the daily routine or life to be better understood and made comprehensible for everyone who is involved in the team. As the project goes on, of course, we see progress. We start with something as rough as possible, try it out, and see if the world is composed harmoniously. Only when we see that the things we've designed work and that we're going to keep them, the level of detail gradually increases. This way we don't put a lot of time into things that we might discard later. That gives the design team the most flexibility possible. We see the same thing with the protagonist. I always like to say we start with the orange blob as a placeholder. Then, over time, we differentiate the character more and more. Let's take a look at the progress at Unity. First, we define an initial world concept to test movement patterns and sequences. Finite state machines were used here to represent behavior in combination with the location of the scene. This is an excellent basis for discussion for the team. If we develop from rough to fine, we can very quickly test things and make them comprehensible for everyone. There is no requirement for beauty here, but for functionality and the answering of questions. We will talk about this in the lecture on usability engineering. Here we see a tree and water. White boxes stand for important places where the protagonist can do things. This world is a good place to discuss and check things in a team. There was also progress in the programming team. For example, the path planning for the protagonist was implemented in Unity. Since water will later play an important role in the interaction with visitors in the lobby, a first version of a moving water surface was developed. Here it is possible to directly influence the movement pattern at different points. Let's take a look at a very advanced version of our interactive ALife-Project after another 4 days. Here the mouse pointer represents a person walking by in the lobby. The grass moves with it, the water as well. By the movement of a passing person, the protagonist can be frightened and hides in the background. When calm has returned, or a person remains standing quietly in front of the beamer projection, it slowly trusts itself to come forward and go about its daily routine. In addition to the visual implementation, the right acoustics were also important for this project. During the project work, we completely forgot that it was actually the lecture Artificial Intelligence. Quite along the way, we learned about a large complex of topics in small on-demand sessions, such as Scrum, the realization of complex behavior, path planning, and so on. This project describes my preferred didactic approach very well. That is all on the subject of brainstorming. Now let's move on to the topic of mind maps. In the so-called mind mapping, mind maps are created. This is a visualization technique that is very popular and describes a network of things and their connections. With Miro, you can create mind maps and other useful visualizations for teamwork. The focus here is on shared access to the virtual board. In a mind map, we first start with the topic and put it in the center. Contributions are now captured and can be related to each other in a structured way. This creates an overview, sequences and priorities may arise, relationships are shown, we can highlight things in color. A mind map supports the creative process and maps it directly. A moderator can typically take over the entries. There are certainly good reasons and many useful examples in which mind mapping proves its usefulness. Personally, I am not a great friend of this technique and think that it is always suitable. What can perhaps be criticized about mind mapping? In the middle is the topic. The other concepts are placed in a tree structure around it and expanded. However, this promotes a pigeonhole thinking. Multiple connections, intersections, even a complete graph are not the goal. Surely it is possible to create circles again in a mind map, but this is not the core idea of a mind map, but rather the exception. This was about mind maps. In addition to creative methods that can be done verbally in a group, there are also brainwriting methods. The 6-3-5 method is one such a brainwriting method. Let's take a brief look at this technique. Here, the basic idea is to develop other people's ideas. First, each of the 6 participants gets a template. There, everyone enters 3 ideas in parallel, briefly and simply. There are 5 minutes available for this. Therefore the name 6-3-5 method. Afterwards, we swap the forms around once. Then we have 5 minutes again to develop the 3 ideas of the others. This continues until all columns are filled in. Theoretically, 108 ideas can be developed within 30 minutes. At the end, the ideas are evaluated and sorted together again. Let's look at an example. The goal is to develop an idea on the topic of intelligent assistants for everyday life. Here we see the names of the participants who are to develop ideas one after the other on this form. So we start from the point of view of the participant Marco. I would like to have an intelligence that receives and sorts emails. Or maybe an intelligence that searches websites, newsletters, magazines for my personal interests. Or how about an intelligence that is fed with all lecture content and can answer all questions? The form moves on to Johann. It has to be said that Johann loves his iPhone more than anything. So we have an intelligence that receives and sorts emails. Simple ones should now be answered automatically and important ones sent directly to the iPhone. We can already see, technologically, he has put his iPhone somewhat in the foreground. He simply wants the intelligence that searches the web pages and the one that provides intelligence to the lecture knowledge to be available on the iPhone as well. Peter now extends the first idea with a ready-made answer pool. The intelligence for website search should learn and deliver the collected content in a compact form. He extends the third idea to include a test scenario where the system can query me on lecture content. Catherine, Georg, and Sabine certainly have some great ideas for further developing the 3 projects. At the end, the ideas can then be evaluated and thus automatically receive a sorting. When I showed this example years ago, I didn't realize that many of these ideas would really become commonplace here so quickly. Since ChatGPT saw the light of day in late 2022, many of these ideas have now been realized. The example has certainly hopefully brought clarity to the work with the 635 method. With Collective Notebook, we have another brainwriting technique. One can definitely say here that there are also very simple techniques. With the Collective Notebook, we have a creative technique where you can develop ideas all by yourself. There are no groups, and whenever an idea pops into your mind, you write it down on a notepad. This creative technique can take several days or weeks. I use this technique very often on my remarkable "Here we see an idea for a house wall greening," which I later implemented so similar on our house. Collective Notebook, very simple. Let's move on to the Headstand Technique. In the Headstand Technique, or inversion technique, we try to turn the original task into the complete opposite. For example, if we are looking for an improvement for teaching, in the reversal technique, we look for solutions to make teaching even worse. In this case, we make use of the characteristic of the human being to grasp something negative faster than something positive. In the end, we also try to turn the solutions around again in order to find new ideas and aspects for the original task. The headstand or reverse technique. Related to this is the so-called provocation technique. In doing so, we want to challenge existing assumptions or experiences and thus create something unexpected. We can also suspend assumptions and formulate, for example, a provocation like "a library has no books," or describe an ideal case like "nobody fails an exam." In a reversal, students could teach professors. An exaggeration could lead to every student getting a degree. We can also put 2 terms together by chance, such as college and pizza. Things may also be falsified. Students are older than professors. After forming these provocations, we try to develop new solutions from them. That's all to the provocation technique. Now let's look at stimulus word analysis. In stimulus word analysis, we want to find solutions and ideas through associations. First, the team defines the problem and then looks for 3 to 5 random stimulus words, for example, random nouns from a book. After that, the words are analyzed in terms of functionality, purpose, and design. With the results, we try to establish a connection to the task. Let's look at an example. The task could be, how can we improve the external image of the University of Applied Sciences in Dresden? We have now collected, for example, 5 stimulus words, and we'll take a closer look at 2 of them, squirrel and bicycle. During the analysis, we might find out that a squirrel is nimble, lives in the forest, or collects supplies. In the case of the bicycle, we remember that it doesn't need to be refueled, but it can be easily stolen, and it is a piece of sports equipment. After the analysis, we try to relate the analyzed characteristics to the problem. How can the qualities of a squirrel be used for Dresden? Or what could be the similarities between Dresden and a bicycle? Up to this point, we have already been very active. With the Osborne checklist, we tend to go into a passive role and just answer questions. The Osborne checklist is for those who still haven't been able to produce ideas up to this point or are struggling with the creative techniques shown so far. We now have a really long list of questions that we can easily work through. If we look at the Osborne checklist, we see 62 questions that are very general. Are there alternative uses? Or is something else like this? Or are there parallels in the past, etc.? That's all to the Osborne checklist. Let us now draw on our own wealth of experience. Analogies are a very good example of using our own wealth of experience. Analogies are about showing similarities between things. In the direct analogy, we could take an airplane, for example, and recognize the wings as an analogy based on examples found in nature. There are also visual analogies. Visual similarities are considered here. For example, design elements of an e-book can be compared with a textbook. With functional or structural analogies, you try to bring things together that might solve similar tasks. For example, the representation of a chessboard in the computer, here represented as bitboards, could give hints for the implementation of a related game. As an example, the Viking chess game, also known as Hnefatafl, is shown here. While searching for pictures on the website Chess Programming, I even found a wiki entry about my chess programming contributions, which go back many years. Analogies are a powerful element. Experience is the key driver of ideas here. Let's move on to another technique called bisociation. In bisociation, two or more contexts are brought together. The contexts don't have to have much to do with the original question at first. Only in the second round, when we combine these things and try to bring things together, can we possibly identify a solution. Here we see machine vision as an example. A robot recognizes things in the world and makes action decisions. On the right, we see an artificial intelligence that, given a formal description of a game, can in principle play all games. This scientific branch of AI is also called general game playing. If we combine both ideas, we can come up with a project idea in which a machine learns a game virtually by watching it via visually and acoustically described game rules and can then play it. We could call this machine Machina Ludens in reference to Homo Ludens. That's all to bisociations. Now let's look at another technique, semantic intuition, which is very related to the previous one. Here we tackle the result first and bring together two terms that at first have nothing to do with each other. Assuming we combine seeing and game machine, we have a seeing game machine, and thus the example from the bisociation, and can consider what this combination could mean for our problem. After listening carefully to this lecture, answering the following comprehension question should help you to summarize the most important statements again on your own.